G'day guys, we've got an applications of calculus question today where we're going to be using incremental change. Now what we have here guys is we have an accurate drawing of a right hand triangle is shown sketched over here. Now the 8 centimeter length is thought to have been drawn very accurately, but the angle of 60 degrees could have been drawn with an error of up to 0.5 degrees. So we have to use differentiation or calculus to determine in centimetres and to one decimal place the possible error in the area of the triangle. Okay, so to start with guys, what I'm going to do is I'm going to label all of our sides. We've got this 8 centimetre side here. We're going to have the height of the triangle, which is here. Let's just write H for height. So we can then write, guys, the area of this triangle is going to be equal to half base times height, which is equal to a half times 8, which is 4 times the height of the triangle. Cool. So what we're going to use is we're going to be able to determine the height in terms of the base using this angle of 60 degrees here. However, we don't know if this is 60 or if it's 59.5 or if it's 60.5. So what we're going to do is we're just going to call this angle for now angle theta. So let's just put an arrow there and call that theta. So what we're going to be able to say, guys, is that the height is equal to 8 times the tangent of theta. Cool. Now, what we're going to do then is we're going to substitute this back into our equation, and what we're going to have is 8 times 4 is 32. The area of this triangle is going to be equal to 32 tan theta. So this is where we're going to use our incremental formula for the small changes in the angle theta. So what we're going to do is we're going to say the error in the area, or delta A, can be approximated by the derivative of A with respect to theta evaluated at the original theta, so it's going to be theta is equal to 60 degrees times whatever the error is in our angle. So what we're going to do is we're going to have to first of all find out the derivative of area with respect to theta. So we're going to take that back over here. So we're going to have dA d theta, which is equal to 32 over cos squared theta. And then from here, guys, what we're going to do is we're just going to manipulate our formula. So we're going to have, well, our error in area is going to be equal to or approximated by 32 over cos squared of pi on 3 times the error in the angle, which is equal to pi over 360. Cool. And what we get, let's just work this out. We can put this into a calculator from here, guys, but it's, a little bit more, it helps you a lot more if you can do all this by hand. So cos of pi on 3 is a half squared is a quarter. Something divided by a quarter is like timesing it by 4. So that first bit is going to be 128 times pi on 360, which we can simplify to 16 pi on 45, which is finally equal to 1.1 centimeters squared, and that's to 1 dp. Cool. So let's just recap what we've done here, guys. First of all, what we did is we came up with a function which we were going to use to express the area in terms of the side we're given, as well as the angle, which is the one that is going to be changing slightly. So what we then did, after we came up with our area formula, 32 tan theta, is we differentiated it because we realized that we were going to need to stick it in here in our incremental formula. What we then did is we evaluated this derivative at the angle which we thought it was, 60 degrees, and then multiplied it by the error. Now, I always put my degrees in radians just so I'm more comfortable that way. So this is the radian equivalent of 0.5 degrees. And then what I did is I just multiplied them both together like the incremental formula asks us to, and out pops our answer. So I hope that quick video helped, guys. If it did, give it a thumbs up. If you'd like to, subscribe to my channel. I put out new videos all the time. Alternatively, if you have any questions regarding calculus or any other kind of high school level maths you'd like answered, be sure to leave them in the comments section below. I'm always looking for new video ideas. But until next time, guys, just keep on practicing, practicing, practicing. Keep banging your head against that wall until the wall eventually falls down. But yeah, hopefully, guys, until next time, see you soon. And make sure you keep enjoying your maths.